when you're asked to solve a right triangle, it means to find the lengths of all of the missing sides and all of the missing angles. This should look familiar from geometry a couple of years ago. What we need to emphasize is that angles are capital letters, sides are lowercase letters. Angle F is opposite side F. Angle U is opposite side U. And angle N is opposite side N. When we're solving a right triangle, we want to remember some facts that all of the angles in a triangle add up to 180 degrees, which means if there's one right triangle, the other two angles would have to add up to 90. That way 90 plus the right angle, 90, is 180. We will primarily use trig ratios, so that's our preferred method, and we'll save the Pythagorean theorem for a last resort. I'll explain as we go through some of the examples. In example 1, we're given 3 pieces of information. We're told that angle A is 90 degrees, angle C is 32 degrees, and side B is 13. The easiest thing to find first is angle B. You could find 90 degrees minus 32 degrees, and that means angle B, 58 degrees. Next, we could find one of the missing sides. It doesn't matter which one. How about we find side C? In order to do that, using the given information, we have angle C. We're looking for the opposite. We know the adjacent. So we would set up a tangent equation. The tangent of 32 degrees is C over 13, opposite over adjacent. To solve that equation, we multiply both sides by 13. Type that into your calculator, making sure you are in degree mode. And you should get 8.12. Now we want to find side A. This is where I suggest you do not use Pythagorean theorem, because what if 8.12 was wrong? If that's wrong, then your next answer would be wrong. So what I want to do in order to find side A is go back to the given information and set up a trig ratio with the given information. That way, if any of my previous answers are wrong, I can still get this part correct. You want to try to avoid using your previous answers in case they're wrong. So the equation I would set up is adjacent over hypotenuse, cosine of 32 degrees is equal to the adjacent over the hypotenuse. We solve this equation a little differently because the A is in the denominator. We have to multiply both sides by A first, and then we have to divide both sides by cosine of 32 degrees. Degree mode on your calculator, and we should get for A 15.33. Now, if you wanted to use Pythagorean theorem to check those sides and make sure they come out, you can, but be careful. The hypotenuse is not labeled C, like you were trained to do with Pythagorean theorem. This time, the hypotenuse is always the longest. So don't go by the letters, go by the actual diagram or the largest value for the hypotenuse. Let's look at another example. Here we haven't been given any of the angles. What we have been given is angle Y, side X, and side Z. If we want to find angle X, we could use the opposite over the adjacent, which is tangent. This means we want to use inverse tangent to find the value of the missing angle. Make sure you're in degree mode. Enter that into the calculator. And you should get 28.8 degrees. Don't forget that degree sign. If you're extremely confident about that answer, you could subtract from 90 to get the other angle. Just in case there was a careless mistake made, you could start all over with another trig ratio. For example, tangent. Again, but this time, tangent of Z would be opposite over adjacent. Use inverse tangent. Put that in your calculator, and you should get 61.2 degrees. Add the two angles that you found, X and Z, together to check your answer. They should equal 90. So that's a good tool to use for checking your answer. Finally, to find side Y, I actually will use Pythagorean theorem. That's the only way to find side Y using given information. Again, I try to avoid using my own answers in case they're wrong. Because if I use a wrong answer, the next answer will automatically be wrong. So here I would use Pythagorean theorem. Calculator, we're going to want to find the square root of 255.29. And your calculator will tell you 16.0, which is rounding to the next step. So we'll continue to solve right triangles with applications, but the nice thing about applications is that we're usually only asked to find one of the missing pieces. We don't have to find all of the missing pieces.